Hi, Geometry. This is page 393. It's the practice 11, number 3. So in this problem, it says that AC is 4, which is labeled right there, and BC is 5, which is labeled right there. And it says a new triangle, DEC, was created by connecting the midpoints of AC and BC. So that I know these are congruent. So actually I know this little part is 2 and that part's 2 in order for the whole thing to add up to 4. And for the same reason, I know that CE is 2.5 and EB is also 2.5 in order for E to be the midpoint. So the area of a triangle is equal to 1/2 the base times the height. So here's the deal. In a triangle, the base and the height have to be perpendicular to each other. So you'll notice this right angle mark at angle C. That means that this is the hypotenuse, or the longest side of my triangle, but it doesn't have anything to do with me calculating the area of this triangle. I would need the perpendicular distances of 2 and 2.5 to be my height and my base, because the values you use in the area of a triangle formula are the perpendicular base and height. So for the little one is DEC. So I'll write the information I've already been working with. I'll write in B. So that would be 1/2 times 2 for this little side, DC, times 2.5 for the other one. The 2 and the 1/2 cancel each other, and so I would just get 2.5 units squared for the area of the little purple triangle. So now let's do the larger triangle. We'll make him green, but he has the same situation. AB, that side, is the hypotenuse. It's across from the right angle, but it really has nothing to do with the calculation of the area for this setup. My area is going to be calculated from the side that's 4 and the side that's 5. So 1/2 the base, which we'll say is 5, or the 4. It doesn't, multiplication is commutative. It doesn't really matter what order they're in. And then this is 20 times 1/2 would give me 10 units squared. So then it says, does the scale factor for the side lengths apply to the area as well? So let's figure out my scale factor. So remember, K, the scale factor, is a side from the image over a side from the original. So it doesn't technically matter which one's which. It says that DEC is the new triangle up here. That was the wording. I'm going to go ahead and say that that's the image then, and then this was my original. So in the little one, I'm going to use the 2 side that's 2 for the image and the 4 for the original. I could use the 2.5 and the 5 though. It's the same thing. Either way, I'm going to get 1/2. So I know that my scale factor between my purple triangle and my larger green triangle is 1/2. This purple triangle is half the size of the big one. So now let's look at the ratio of the areas. So now let's do a ratio of the areas. Well, the area of my image, the purple one, was 2.5. So we'll write that on top. That would be like my image area. So this is like my image area divided by my original area, because I'm trying to see if that has anything to do with the scale factor. So that is 2.5 over 10. And when I reduce that, so I want to compare it to 0.5, I could do that a couple ways. 2.5 divided by 10 is 1/4. So I could write that as 1/4. You could write that as 0.5 and 2.5, however you want to do it. But the point is they don't seem to be the same. So I want to mention something that's going to come up in a later unit. The scale factor is the ratio of my perimeters. My perimeters, the distance around my triangle and my sides, follow the scale factor. The area, the scale factor for area is actually my K squared. So that's really how my areas relate. The scale factor for my areas, if you will, would be 1/2 squared, which is 1/4. And actually volume, we're going to find out in a later unit, volume is my scale factor cubed. So 1/2 times 1/2 times 1/2, which would actually be 1/8. And so that's going to come up later. So does the scale factor for the side lengths apply to the area as well? No. The scale factor of the areas turns out to be 1/4. Thank you very much.